Let's do problem 41 on page 144, and let's read it. Here it is in the book. It says a 3 kilogram block starts from rest at the top of a 30-degree incline and slides a distance of 2 meters down the incline in 1.5 seconds. We want to find the magnitude of the acceleration, the coefficient of kinetic friction between the block and the plane, the friction force acting on the block, and the speed of the block after it has slid 2 meters. Oh, the speed, okay. So, so let's set this up. Given. So what did it say? We had a 30-degree incline, right?
Yeah.
And so here's our block up on the incline. And it says it starts from rest. And that's a really important clue. Whenever it says it starts from rest, you know that V naught equals 0, right? Okay. And then, and it slides down a distance 2 meters in 1.5 seconds. So here we'll say, here's the block towards, I don't know, at the bottom. And we'll say that delta x equals 1.2 meters. So it slid down all the way to there. And it's here when time is equal to 1.5 seconds. Oh, thanks. Yeah, it's 2 meters. I don't know what the heck. Okay. And let's see. And here's what we're trying to find. We want to find, it says, A, the magnitude of the acceleration of the block. B, the coefficient of kinetic friction between the block and the plane. U sub k. C, the friction force acting on the block. So there's our symbol for friction force. And D, the speed of the block after it has slid 2 meters. So we want to find the speed. Okay, so let's solve. Some of these look like more like kinematic things, like A and D are you could just probably use the kinematic equations to solve it. Let's do that when we're given a displacement in time, initial velocity, and we're trying to find acceleration. Well, which kinematic equation would we use here? See, we know, well, think about it. What do we not know and not need for part A? Well, we don't know the acceleration, but we're trying to find it. So we want an equation with acceleration in it. We know the initial velocity, we know the time, we know the displacement, but we don't know the final velocity, and we're not trying to find it yet. So I'm going to use the third kinematic equation, and I just have it memorized, but you should have an equation list where you keep all of these things, keep track of all these things. So this is V naught t plus 1/2 a t squared. Let's make down the incline the positive x direction, and we'll make perpendicular like that the y direction. V naught is 0, and so now we can solve for the acceleration. Acceleration is equal to 2 times delta x over t squared. Does that make sense so far? Did you get this part, or did you get this far on it? Okay. So you just use the kinematic equations. When they're asking for an acceleration and they give you all this kinematic information, you can probably figure it out that way. And then you have 2 times 2.00 meters, 1.50 seconds squared. So why don't you tell me what that is. Well, let's see, it's 4, what is that, 320 or 3.25, something like that.
1.7, yeah,
1.7, 1.78,
yeah.
if you round it to 3 meters per second squared. Now I can check that because we have the answers in the back of the book. And I look at number 41. A is 1.78 meters per second squared. We got it right. So put a star next to that. Got it right. And then let's do part B now. We want the coefficient of kinetic friction. And so now we're getting into forces and stuff. See, in order to get the coefficient of kinetic friction, I need to know what the force of friction is and what the normal force is and all that sort of thing. So now I'm dealing with forces. So now I have to use that procedure where we're looking at the forces acting on the object. We have to draw the free body diagram. So let's do that. That's our first step. Here's my crate. And of course, gravity pulls it straight down. Right? And then we have a normal force like that. And then we have a force of friction like that. Now, of course, let's look at what we're trying to find. We're trying to find mu. So I can say, well, the coefficient of kinetic friction is equal to the ratio between the force of friction and the normal force. Okay, so that's just something you need to know. Should be on your equation list. And and by the way, how do I know that this force of friction is pointed in that direction?
Because it's the opposite of where, like, which way it's moving.
Yeah, the crate is sliding down the incline. So that interaction between the crate and the incline, that friction force that's on the crate will push it up, or on the block. I think they called it a block in the problem. All right, so now we've already said that this is the x direction and this is the y direction. And so we have to take the weight now and break it up into its x and y components. And so this is, and remember we said on an inclined plane problem that if this is the angle of incline, that angle is right here. So this is 30 degrees right here. So this is going to be mg cosine theta, because it's the adjacent leg. And this is mg sine theta. Okay, so I'm following the procedure. You know, you have to draw the free body diagram, identify your x and y axis system, and then break up the forces into their x and y components. The normal force is in the y. The force of friction is already in the x. Just the weight has to be broken up. And we express those components in terms of the angle of incline. Okay? So now I can go on to step 4. If I sum the forces in the x direction, that's going to be equal to ma. But I know what A is now, right, from part A. The force of, so we've got mg sine theta minus the force of friction equals ma. Now, we might as well solve for the force of friction right away. Even though it's part C, because look, it's right here, and we know all these things. We know the mass. Well, we do know. I didn't write it down though, did I? It's a 3 kilogram block. I forgot to write that down in what's given. M equals 3 kilograms. But so now I can just solve for the force of friction. I'm just going to do it in one step. So just add it over there and subtract this. So this is going to be mg sine theta minus ma. Okay, did I do that right? Plus and then minus, yes. And so now I can just plug in my numbers. I'm going to distribute that out. That's 3 kilograms times 9.8 meters per second squared times the sine of 30 degrees minus the acceleration was 1.78 meters per second squared. And when you plug all that into your calculator, what do you get? So go ahead and plug all that in. Follow along, you at home. And
Put it in degrees.
you get, well, according to the book, you get 9.37 newtons.
Yeah, I got that.
Okay. Well, that's my answer for part C, so I'll just put a C right here, and we looked it up, and that's correct. But I really want to get that coefficient of friction over here, so I have to figure out what the normal force is to do that. So let's sum the forces in the y direction. That's going to be equal to 0 because this crate is not accelerating in this direction at all, and that's always going to be true for inclined plane problems. So in the positive y direction, I've got the normal force minus this force, mg cosine theta, and those are the only forces, and so we get the normal force is equal to mg whoops, what did I do that for? Mg cosine theta. And now we can plug in the numbers. N equals 3 kilograms times 9.8 meters per second squared times the cosine of 30 degrees. And what do we get when we do all that? Let me come up with an estimate. This is 3 times about 30, I don't know, about 27, 26?
25.46.
25.46 newtons. Okay. Because a kilogram meter per second squared is a newton. Now we can figure out what mu is. Woohoo! So mu is equal to the force of friction divided by the normal force. The newtons cancel. And what do we get? 0.368. Now let's check that. And 0.368. Woohoo! That's right. So put a big star next to that one.
Is it 0.363?
Or 8. Yeah, golly. See, this is why you're here, is to keep me from making bonehead mistakes. All right, and then now we can figure out the velocity, the final velocity, but we really don't need what the force of friction is or any of that. We just, this was part, this was part,
that was part
B right here. For part, well, what do we know? We know we want the final velocity. We didn't know the acceleration, but we did know the displacement, and we knew the time. So what doesn't have acceleration in it on our equation list for kinematic equations? The second one, yes. So we say delta x is equal to the average velocity, which is v plus v naught divided by 2 times time. And so I'm going to solve it for this. Now this guy was 0. So V equals 2 times delta x divided by the time. So that's going to be 2 times 2 meters divided by 1.5 seconds. 2.666. 2.67 is probably good enough, yeah. 2.67 meters per second. And that's my final velocity. I'm kind of squeezing it in here. Now let's see if that's right. And look it up. Yay, 2.67. Perfect. So let's see if we can get the whole thing in here. Let me lift the camera up a little bit. And so here's your whole problem. So we used, we did give and find and solve. We set it up very carefully, drawing, you know, how to set it up. You know, this is strictly a kinematics problem at first. And then, but then to find this stuff, I had to use that force procedure. And then to find D, we used kinematics again. Okay? Then, you have any questions on this? Okay, here's what I want you to do. And if you're listening at home, this is what I want you to do. Do this problem over again. Do it tomorrow. Well, think about it right now and study it. And then do it all by yourself without looking at this tomorrow. And if you can repeat it and understand all the steps, then you've really got it. Okay? All right, that is all.
Thank you.